Okay, how are you doing? Inshallah, we revise lesson 1 and lesson 2 in chapter 2 physics. Okay, lesson 1 is talking about what? Motion. Lesson 1 is talking about motion. We said before what is the meaning of motion. Okay, we said motion when an object changes its position, we say that the object is in motion. Okay, when an object changes its position, we say the object is in motion. And we said we have many kinds of motion, many kinds of motion. We said we have four kinds. Okay, four main kinds. We have linear motion, when the object changes its position from point A to point B, maybe moving in a straight line, okay, or forward, so it's what linear motion. The second motion is a circular motion, when the object moves in a circle. Okay, so this is the first one. The second one is circular motion. The third one, we said rotational motion, when the object rotates around itself, and we must have an axis, and the object rotates around itself, like the Earth when it rotates around itself. Then we said the fourth kind, we talked about periodic motion. Periodic motion, okay, it's like a wave motion, and for periodic, the object repeats its motion in equal time intervals, okay? So the motion is repeated for every 1 minute, 2 minutes, 3 minutes. So the motion repeats itself at the same time. Okay, so now we have on this page, you have to know that what is the meaning of motion? It changes in position. Okay, what are the types of motion? We have four kinds. Number one, linear motion. An object moves in a straight line. Number two, circular motion, when the object moves in a circle, like Earth revolving around the sun. Number three, rotational motion, when the object rotates around its own self or around its own axis, like the fan at our homes, okay, or when Earth rotates around itself, okay, it's called also rotational motion. And the wheel of your car, okay, the fourth kind, we said it is periodic motion, like the wave motion of water waves. Okay, and this motion is related to time. It means the motion is repeated each equal time intervals. Okay, so this is about the meaning of motion and the kinds of motion. Okay, then we talk how can we describe motion? To describe motion, we need two things. Number one, we need the position, okay, the position, and we need what? The time, okay? And we say we can ask about position by using a question starting about where. So where referring to what position? So how can we describe motion? By measuring the position and measuring what time. We can ask about position by where. We can ask about time by when. Okay. So describe motion. We need to know position and time. We need to know position and time. So we can describe motion using what words. Using what? Number one, to describe motion, you can describe motion using what words. Okay? You can ask question like when and where. The second one, we can use models. Like the first one here, we said motion diagram. Okay, so we can describe motion using number one words, number two motion diagram, number three, another model is what? Particle particle model. Okay, and the fourth one, using what? Tables. We said we can use tables to describe motions. And the fifth one, we can use what? Graphs. Okay, so from lesson 1 to lesson 2, we said we can describe motion using words, using motion diagram, using particle model, model, then you can use tables, and from the tables you can draw a graph. So these 5 ways you can describe what motion. Okay, you can describe motion. So we said by verbs you can ask questions like when, where to describe motion. Okay. The second, we can use model like motion diagram. We said what is the meaning of motion diagram? That you take an image, okay? So we said what is the meaning of motion diagram? Is a series of images showing the positions of a moving object at equal time intervals is called what? A motion diagram. So we have successive images of the moving what? Object, of the moving object. So we call what? A series of images showing the positions of a moving object at equal. So it shows two things. Number one, position. Number two, the time. Okay. So we have to measure motion, we need position and time. This is what motion diagram. Then we have particle model. We have particle model. What is the difference between motion diagram and particle model? In particle model, we replace the object using what? Single points or single dots. This is the object, this runner, this girl, we replaced it using single points or single dots. So a simple way, what is a particle model? Okay. In a particle model, you replace the object or objects of interest with single what? Points, with single points. Okay, and also the single points will give you the time and the position. So now we finished the two models, particle model and motion diagram. Now we move to listen to. Okay, we said how to make a good motion diagram particle model. Okay, we have to use what? To measure the motion. Well, if you need to measure motion, so you have to make a coordinate system. If you want to measure anything, you must use a measuring tool and a measuring system. Okay? If you want to measure anything, you need a measuring system. Okay, and this measuring system must be a starting point. A starting point. The starting point for the coordinate system is what? Is the origin. And in simple way, if you make an axis, okay, like this one. So your starting point would be 0. And you will go on like this one, 2, and so on. So 0, here we have a meaning for each number. 0, we call it what? Origin. At origin, okay, there is no value if this represents time or represents position. Okay, at 0, there is no value for position and there is no value for time. Position is a variable, time also is a variable. Okay, so both variables have value of 0. So what is the meaning of origin? Origin is the point at which all variables in a coordinate system have the value 0. So what we did now is called coordinate system. Okay, so what is the meaning of a coordinate system? The coordinate system gives the location of the 0 point. Okay, we located the 0 point of the variable you are studying. Maybe you are studying time or position, and the direction. Here I set x-axis, so I make an arrow. It indicates the movement of direction is to the right, in which all the values of the variable what increase. So the value is increasing in this direction. So this is the meaning of coordinate system. It gives you the location of the 0 point of the variable you are studying and the direction in which the values of the variable increase. Well, again, what is the meaning of origin? It's the point at which all variables in a coordinate system have the value 0. And all of these things, I think, are easy because we are talking only about the definition. Okay, but you have to understand what does it mean when we transfer it into drawing. Okay, and also how can we indicate how far the runner by drawing what? An arrow from the origin to the point that represents what? The runner, like this one. If you want to stop here, so he presents his position. If he stops here, if he continues to move, so you can make an arrow to the new position. Okay, and this arrow we said represents what? This arrow represents the runner's what? Position. Okay, right. We have another term which is called distance. We said distance is the entire length of an object path, even if the object moves in many directions. If I have point A and the object moved in this direction, this in this one, then he moved left, then come back here, and okay, and then come back to reach point B. Okay, if this 5 meters, and this one is 3 meters, and this one is 4 meters, and this one is 4 meters, and this one is 5 meters. So the distance, the object move, the distance, okay, distance, as he said here, the distance is the entire length of object path. The entire, what is inside the length, what is the entire, the whole length. So from the starting point to the end point through the path. So we'll move, we will follow the whole path. We will follow the whole path to measure distance. So 5 plus 3 plus 4 plus 4 plus 5. Here we have 5, 3, 4, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So what is the distance? 5 plus 3, 8, 12, 16, then 21. 21. So this means what? That is the distance, the object what traveled. Okay, but we'll talk now about displacement. So this is distance, but what is displacement? Displacement, no, displacement has is the distance. Displacement is the distance from the starting point to the end point, or from the initial position to the final position. Here the initial position or the starting point is A, the final position or the end point is B, and we have to measure this one. So now we know the direction, and it must be measured in a straight line. Measured in a straight line. So we measure directly from A to B. From A to B. This is the displacement, because we have to position initial position and final position. Okay, if we measure this one and we found it 10 meter, okay, so the displacement equals 10 meter. Okay, so there is a big difference between distance and displacement. Okay, distance, we measure the whole entire path. Whatever we moved, we will measure it. And this is in distance. Okay, but for displacement, no, displacement care about a change in position. I told you before, if you are sitting on your desk and you went to the board and you move to the door, you go out, then you come back sitting at the same desk. So there is no change in your position, because the starting point and the ending point are the same. Okay, this is what we mean displacement, a change in position. But if you change it, your desk, see the words, when you change your desk to another desk beside you, so you change it your position. So at this time you can say I have a displacement. You have a change in your position. Okay, we have a lot of questions, and also this point will be explained again. Okay, distance and displacement. Okay, could we have negative position? Could we have negative position? Can give you a question like this. Could we have negative position? Yes, we could have negative position. If this is the coordinate system we are using, and this is the origin point, okay, so this we said this direction indicates what? It is increasing in this direction. So this P could be positive x-axis, and this P could be negative x-axis. And we said positive and negative indicates what? Direction. So negative position It means if the object was moving to the right, then it changed moving to the left. So it means what? We can say like this one. If the object first covers 5 meters, we can say positive 5 meters. So it means he moved to the right. If I said no, the object moved minus 5 meters, what you have to understand that it moved to left. So if I ask you, true or false, position could be negative, true or false? Yes, true. Because we said a position left of the origin would be a negative position. Okay. Could we have a negative position? Yes, we could have a negative position, and this indicates that the object is moving in the opposite direction. If we are using this coordinate system, this one is to right and this one to left, or east and west. So if it means it's moving to negative x direction or left or west. Okay, this one when we say negative position. Okay, then we have vectors and scalars. Vectors and scalars. We said any quantity that you can describe by number and direction, we call it what? A vector. So many physical quantities has size, and size we call it what? Magnitude. And direction. So we must have size plus direction. Okay, must have size plus direction. Okay, we said what is the meaning of size? Size means magnitude. What does it mean? Number. So when I say the displacement, okay, equals 5 meters to east. So what is 5? 5 is the size or the magnitude or the number. So this number, what is another name? We have three names for this. Number one, the number, or the size, or the magnitude. What is E? E is referred to east. So it is what? The direction. So any physical quantity you can describe using both its magnitude and its direction, we call it what? Vector. We call it what? Vector. Okay? So a quantity that has both magnitude and the direction is called a vector. And to represent a vector, we use what? An arrow. When I draw an arrow like this one, so I represent what? A vector. And the length of the arrow represents the magnitude of the vector, this length. So when I write 5 meters, so you have to know that this length is what? Is 5 meters. Okay, and the direction of the arrow represents the direction of the vector. This is the direction using the head of the arrow. Okay. Another quantity which we call scalar quantity. Scalar quantity. A quantity that is just a number without any direction. What we call it? A scalar quantity. What we call it? A scalar quantity. Okay, like distance. Okay, like speed. So you have to know different examples about vectors and scalar as we said before. Okay, and now we will discuss some concepts about is this quantity vector or scalar. Time interval. In general, we said time is what? Is a scalar, right? We said in general, time interval are scalars. Time intervals are what? Are scalars. Why they are scalar? Because they have no direction. Okay, or we can describe them only using what? A number or a magnitude. Okay, so what is time interval? The difference between two times. We call it what? Time interval. So what is the definition of time interval? The time interval is equal to the change in time from initial time to the final time. If I give you a line like this one, and this is 0, and here 1, and then we have 6. So this and this we are talking about time, measuring unit in second. So 6 is the final time, and 1 is the initial time, or the starting time, and this is the end time. Okay, so what is delta t? Delta t time interval. we call it what? TF minus TR. Okay, so it means 6 minus 1, so equals 5 seconds. And this one, okay, this time we need only number to describe time. Why? Because it is a scalar. So time interval is a scalar? Yes, true. Why? Because it can be described using a number only. Okay, we can describe time or time interval using only what? A number. Or you can say the time interval is a scalar because it has no direction. Position and displacement. We'll repeat it again. It's the same thing when I say I have point A and point B. This is the first position and this is the final position. Okay, so if you are moving from A to B, it means you changed your position. So we have two positions. We call it what? This is A. This is the initial position, and we will give the position symbol x. So we have two position, 2x. How can we differentiate between them? This is the initial position or the first position, initial, we give it I, and the final position, we give it F. So now we have a change in position, and we said in physics, we give the symbol delta to refer to change. So a change in your position means the final position minus the initial position. Okay, delta x means what? Displacement. Delta x means what? Displacement. So delta x, a change in position, which refer to displacement, equal the final position minus the initial position. Final position minus the initial position. Okay. So if I give you different problems like this one. Okay, let us consider that you are moving here, you moved this one. Pay attention for this example. Okay, if this is 0, so this one coincides with this one, and also the same ending here, we have the R or parallel. Okay, there is 2, 4, and this one is 6. This is the line that gives you, this is your coordinate system. So what is the position? You look to the arrow. You look to the arrow. Pay attention for this one. This is your coordinate system. This is the coordinate system. This is your coordinate system. Okay? But where you measure, when you have a problem like this one, where from the arrows, where you measure from arrows here. Okay? Where you measure from this arrow. Okay, so you started from here, you crossed here 6, then you change it and you take also this, you move the back this one, and you stopped at 4. So what is your distance? Distance is the total you have moved. The first one, this is the first arrow, you moved what? 6. Then you came back. From 6 to 4 is what? 2. The difference is 2. This one is 6 and this one is 2. So 6 plus 2, so your distance is what? 8. But when I say displacement, delta x, okay? Delta x. What is your initial position? Pay attention for this one. Your initial position was at here. This value is xi. It is what? 0. What is your final position? Your final position, you stopped here. You stopped here. So this is xf. And if you look to the xf equals 4. So 4 minus 0. So your displacement is 4 meter and your direction is to left. Okay? So there is a big difference when I ask you for this life of drawing. what is the distance and what is the displacement. These like two questions. Okay? Distance, you will measure the whole movement, but displacement, you will say, where is the final one? This one. Where is the initial one? This one. So the final minus the initial. The final minus the initial. Hope this point is clear. Okay, this is for displacement. We have another one here, a vector resultant or the resultant of two vectors. We said what is the meaning of a resultant? A vector that represents the sum of two other vectors is called what? Resultant. We said if we have two vectors like in the same direction, so we will add the two vectors like vector A and vector B. يبقى resultant R equal vector A plus vector B. Vector A plus vector B. Okay? Because they are even they are to the right or they are moving to north, they are or down, they are in the same direction or left, they are in the same direction. It means we will make addition. Why we make addition? Because they are in the same direction. They are in the same direction. Okay? And when we have to make subtract, if they are in opposite direction, if they are in opposite direction, like this one here. Here we have vector A. This vector is to the right, right? This is arrow, and we have vector B, and vector B is to left. Vector A is 7, so the resultant are, we set A plus B. This is the general law. But if you look to A to the right, so it will stay positive. But B is to the left, so we have to change to R equal A minus B, because B is to the left. Okay, they are stay in the same axis. They are moving in x-axis. Okay, so and you replace A by 7. You replace A by 7, and you replace B by 4. So 7 minus 4 is equal to 3 kilometer, and you have here to mention which what direction. 3 kilometer what? East. 3 kilometer east. Okay, so this is how to find the resultant of two vectors. If they are both in the same direction, we make addition, like 5 plus 7, 5 plus 2 equals 7 because they are in the same direction. This one 4 and this one 6, so it is what 4 minus 6 equal minus 2 because they are in opposite direction, I think this is the last point here in lesson 2. Just some notes for you. The quiz only on lesson 1 or section 1 and section 2. Section 1 and section 2 only. Okay. Now I'll take questions if you have any questions.